Knowledge is what gives humans opportunities and influence. And knowledge, or the attainment of knowledge, is what we teach here at NTNU. NTNU gives more than 370 degree-giving courses every year. We have more than 42,000 students spread over 3 cities in Norway. And for every year, we graduate 400 PhD students. This goes to show both the breadth and width of research, as well as the depth of it. The world has, through the UN, agreed on 17 sustainability goals. These sustainability goals play a large role in both our research and teaching at NTNU. For each project and each assignment, we consider how our work will contribute to these sustainability goals. A large part of NTNU's funding comes from external sources and are won in competition with others. This shows that NTNU is both a conscious and competitive institution at the same time as being a great platform for learning and teaching.
I'm Haley Hoover. I'm a PhD at NTNU with the Department of Material Science, and I work with silicon production and studying the electrical resistivity of transformed materials in the silicon process. So one of the reasons that we study electrical resistivity is because we know that the silicon process is very energy intensive. It takes a lot of electrical energy, and we want to look at how that energy is distributed once it goes through the furnace. We want to look at the various paths that the current can take through the electrode. So we study the resistivity, which is the inverse of conductivity, if you want to think of it like that, as a way of understanding where the current can go once it enters the furnace. We study the resistivity of these various materials as they are transformed at high temperature. So that's kind of like the main purpose of the project. But on a larger scale, understanding these current paths in the furnace allows us to reduce the energy consumption and, by extension, CO2 emissions, which is of course always the larger goal of projects like this.
I'm Trygve. I'm a PhD student from the department, and I'm part of a project called Reduced CO2 Emissions in Metal Production. This project is about researching new technologies that can remove CO2 emissions from the Norwegian metal producing industry by 2050. My part of the project is about researching the use of hydrogen in silicon production. This is important because without finding ways to replace the fossil carbon that is currently being used to make silicon, removing the CO2 emissions from the process will be impossible, no matter how green and the energy source that is powering the furnace is. These kinds of technologies will be essential in helping the Norwegian metal producing industry transition into being climate neutral.
My name is Hamide Kafash, and I'm a postdoctoral researcher at the Material Engineering Department at NTNU. We all agree that biocarbon is a promising alternative to fossil reductants for reducing greenhouse gas emissions and increasing sustainability of metallurgical industry. Compared to conventional reductants like met coke, pet coke, and coal, charcoal has low density, low mechanical properties, for example, low compressive strength and high CO2 reactivity, which are undesirable for ferroalloy production. Densification is an efficient way to upgrade biocarbon properties. In this project, we are using a novel and clean technique to densify charcoal, which is using methane. Methane is cracking at the experimental temperature that we used, which is 1100 degrees C, and the carbon which is coming from the cracking of methane is depositing on the surface of carbon and also inside the pores. So with this technique, we could decrease porosity of charcoal by 28 to 38%, increase compressive strength by 7 to 15 times, and reduced CO2 emissions by 28 to 40%, which is very interesting. For densification experiments and also potassium impregnation experiments, we are using an induction furnace, which name is NTEC furnace, which is owned by Sintef, and the maximum operation temperature is 1450 degrees C. In this furnace, we are using a steel crucible and we are putting our material inside.
My name is Merete Tangstad and I'm a professor at the Norwegian University of Science and Technology. The Norwegian University of Science and Technology is the highest ranking university within technology in Norway. Both alumni and the newly graduating students are very proud to wear the NTNU ring. At NTNU, we are doing a combination of research-based teaching and also applicable and fundamental research. And we also have the best students in Norway. At Material Science and Engineering, silicon and ferroalloy production are focused within teaching and research. UN sustainability goals guides the direction of our teaching and research, and as such, the reduction of CO2 emissions, the reduction of other emissions, and the reduction of energy consumption is an important part of the research. Our strength is the people. It's the cooperation with Sintef, the Norwegian industry, and as well as the international industry. And also, the strength is the wide range of high temperature experimental equipment ranging from milligrams to hundreds of kilos.